Good afternoon to all. My name is Ramakrishna, your chemistry teacher. Chemistry deals with number of general life, mostly soaps, detergents, cloths, solid particles, liquid particles, gaseous particles, number of chemicals, tablets, medicines, drugs, insecticides, pesticides, even water. Water is also chemical. So chemistry deals with huge varieties in our general life, but only one main part is present in chemistry. That part is an atom. Atom is a smallest particle in the universe. Smallest particle means there is no possibility to cut that smaller one. Best example for atom, take this chalk piece, do like this, small dust particles are fall down, take one dust particle and cut with blade, it is divided into two parts, take only one part, again cut with blade, it is again divided into two, cut, finally a smaller one, means there is no possibility to cut further. The smaller one is called an atom. So simply, what is atom definition? Atom is an uncuttable particle or indivisible particle. This definition was given by John Dalton, and the theory is called Dalton's atomic theory. This is the first lesson in chemistry, and also it is a basic lesson of chemistry. Dalton's atomic theory. John Dalton said atom is a uncuttable or indivisible particle. Example for atoms are hydrogen, lithium, sodium, oxygen, potassium. These are all atoms. But one small confusion is there. All of you write the running notes. One small confusion is there. Sir, I think these are all elements. Yes. From the elements, we pick a smaller one, very smaller one. And the best explanation for this one, take one glass of water. What is the general formula of water? H2. How many water molecules present in one glass of water? Infinity. But the smaller one is H2. Of course, H2 is a molecule, it is not an atom. Same explanation. For example, this chalk piece made with one type of atom. So, take the smaller one from this chalk piece, the smaller one, or the uncuttable or indivisible one is called an atom. Another example, if you take one iron rod, actually iron is an element. Iron rod contains only iron atoms. That iron atoms are combined by metallic bond. So from the iron rod, take a smaller one. That smaller one is called an iron atom. So these are all elements. From that elements, just I am taking only smaller one. The smaller uncuttable hydrogen, uncuttable lithium, uncuttable sodium, uncuttable oxygen. That's why these are all taken as atoms. Simply, what is an atom? Atom is an uncuttable or indivisible particle. Right. So, atom definition is given by John Dalton atomic theory. Good. But so many physical scientists, so many members, physical scientists are discussed about atom, and research for atom means they done number of experiments on atom. They are finally realized that atom is not a smaller particle in the universe. Why? One small reason is there. Before the explanation of that part, I will give one example. One person said, ant is the smallest one. But we know that ant contains eye, leg, some body parts. What about those parts? Those parts are smaller than ant. For example, my body is the smaller body we are considering. What about our hands, our fingers, eyes, ears? These are all smaller than our body. The same explanation for atom also. Physical scientists realized that atom is not a smaller particle because atom contains so many number of smaller particles present inside the atom. Those particles are called subatomic particles. Subatomic particles means simply that this definition is not correct one, but still we are following this definition. But atom contains number of subatomic particles. Those subatomic particles present inside the atom. So remember this point. Okay, next one, molecule. What is molecule? Combination of atoms gives molecule. Combination of atoms gives molecule. Examples for this one. H2. They are combining two hydrogen atoms. N2. Combination of two nitrogen atoms. O2. Two oxygen. O3. Three oxygen atoms. S8. Eight sulfur atoms. These are all one category. And another type of molecules, H2O, H2SO4, HNO3. What is the difference between these two? These molecules contains only one type of atoms. But these molecules contains different types of atoms. Two hydrogens, one oxygen present in the H2O molecule. So one is hydrogen category, another one is oxygen. So two different type of atoms. See this molecule H2SO4, sulfuric acid. In H2SO4, two hydrogens, 1 sulfur, 4 oxygen atoms are present. So 3 types of atoms are present. HNO3, 1 hydrogen, 1 nitrogen, 3 oxygens. So here also 3 types of atoms are present. Total atoms 1, 1, 3. Total 5 atoms. So these are all called elementary molecules. Elementary molecules. This type of molecules are called compound molecules. What is these two are types of molecules? Molecules are classified into 2 types: elementary molecules and compound molecules. Elementary molecules contains identical atoms, but compound molecules contains different atoms. And write one more point: elementary molecules nothing but homo molecules. Homo molecules. Homo means same. Compound molecules are nothing but hetero molecules. Hetero means different. This is about what is an atom and what is a molecule. All of you write the running notes. Next one. Atomicity. Atomicity means number of atoms present in the molecule. Number of atoms present in the molecule. Example, H2O. What is the atomicity of H2O? How many atoms are present in the H2O molecule? 2 hydrogen atoms, 1 oxygen atom. So atomicity is equals to 3. H2 atomicity 2, because only 2 atoms are present. Total number of atoms present in the molecule is called an atomicity. H2SO4, 2 hydrogens, 1 sulfur, total 3, plus 4 oxygens, total 7. This is about atomicity. Next concept, subatomic particles. I already told you what are subatomic particles. Subatomic particles means some particles present inside the atom. These are called subatomic particles. Particles present inside the atom are called subatomic particles. Those are electrons, protons, neutrons, positrons, mesons, etc. So many subatomic particles are present, but among these only 3 particles are important. That particles are called fundamental particles. Fundamental particles. Are you understand this one? Fundamental particles means 3 important subatomic particles present inside the atom. The three fundamental particles are called, sorry, the three subatomic particles are called fundamental particles. What are those? Electrons, protons, and neutrons. These three are most important subatomic particles. That's why these three are called fundamental, means main particles in the atom. Right. Next, what are the symbols of fundamental particles? Symbols of fundamental particles. Right. Symbol of electron. Symbol of electron is equal to E minus. Remember this point, E minus, not E. E means it indicates charge of the electron or charge of the proton, right? It indicates charge. But E minus means electron. Next one, symbol of proton equals to P. Not plus is not there, because another P plus, it is P plus another subatomic particle present in the atom. Third one, symbol of neutron equals to N. Electron symbol E minus, proton symbol P, neutron symbol N. Electron is negatively charged particle. Negatively charged particle. Proton is positively charged particle. Proton is positively charged particle. But neutron is neutral particle. Neutral particle. These three are fundamental particles. Electron symbol E minus, proton symbol P, neutron symbol N. And electron is negatively charged particle. Proton is positively charged particle. Neutron is neutral particle. Now position. Position of fundamental particles. This is the most important one. In any atom, one center is present. Not only an atom. In our universe, every matter consists one center. For example, for our body, this part is center. For this room, that middle one is called a center. For this chalk, for this duster, this in the middle one, inside the middle one is a center. So, its center is most important for any substance or compound present in the universe. So, atom consists of only one center, one nucleus. This is center of the atom. For example, it is an atom. The center, the middle point, this is the center. This center is called nucleus. This center is called nucleus. And inside the nucleus, protons and neutrons are present. Inside the nucleus of an atom contains protons and neutrons. And one more fundamental particle is there, that is electrons. But electrons are revolve around the nucleus. These are the electrons. Simply, what is the position of electrons? Electrons are revolve around the nucleus. Position of protons and neutrons, both protons and neutrons are present inside the nucleus. Inside the nucleus. Next one. Atomic number. Atomic number. Atomic number is denoted by the symbol Z. Atomic number is denoted by the symbol Z. And Z equals to, very simple, Anna. Remember this point, very important. This is nucleus of an atom. Inside the nucleus, protons and neutrons are present, but electrons are revolve around the nucleus. Z means number of protons or number of electrons. So in any atom, same number of electrons and protons are present. So what is the Z? Z equals to number of electrons, or Z equals to number of protons. See the example here. Example, sodium. Sodium atomic number Z equals to 11. So 11 means it contains 11 electrons and 11 protons, because same number of electrons and protons present in the atom. But this is very important. Na plus. What is Na plus? Na plus means, here plus means plus 1. In mathematics, plus means addition, minus means subtraction. But in chemistry, it is reverse. Plus means subtraction, minus means addition. Here plus 1 means subtract 1 electron from the total electrons, or simply remove 1 electron or lost 1 electron. So Na plus means, here actually Z is equal to 11, because sodium, it is a sodium, but it lost 1 electron. So don't write Z is equal to 11. Actually sodium is, Na plus is formed from Na. Na plus is formed from Na. Initially Na contains 11 electrons, but Na plus means it lost 1 electron. So Na plus contains only 10 electrons. What about protons? Protons are same, 11 protons. Sir, what is the reason, sir? Very simple. Electrons are present outside the nucleus, and they revolve around the nucleus. So here there is a possibility to remove the electron. Okay, can you remove your heart by using your hand? Can you remove your heart? No, because skin is present, the surface covered with skin, and inside that heart is covered with bones. So that heart place is the nucleus place. Just example, it is an example. Okay, so first you have to remove outside surface, means skin from our body. Similarly, here also we have remove first electrons, because electrons present outside the nucleus, but protons and neutrons are present inside the nucleus. Inside the nucleus. So there is no possibility to remove protons and neutrons. Only one possibility, that is we can remove or we can add electrons only. Okay, so for Na plus contains 10 electrons but 11 protons. One more example for this one. S2 minus. What did you know about sulfur? Sulfur atomic number 16. Sulfur atomic number 16. 16 means how many electrons are present in sulfur? Sulfur, not for this one, sulfur, for sulfur atom. For sulfur atom, how many electrons are present? 16 electrons. How many protons are present? 16 protons. But it is not a sulfur. It is sulfide ion, S2 minus, sulfide ion, S2 minus. So if 2 minus means minus 2 is present, minus means addition. So 2 more electrons are added. So initially 16 electrons are present, 2 more electrons are added, so 16 plus 2 electrons, that is 18 electrons are present in the S2 minus ion. S2 minus ion. But how many protons are present? Only 16 protons are present. Are you understand this point? Very simple. Without any charge, that one is called neutral atom. Neutral atom. Na is neutral atom. Neutral atom. But Na plus is ion. What type of ion it is? Positive ion. Positively charged ion is called cation. What is the name? Cation. S2 minus. S2 minus. It is also charged ion. Charged particle is there. 2 minus. It is also called ion. It is negatively charged ion. Negatively charged ion is called anion. So simply remember one point here. Neutral atom contains same number of electrons and protons. But cations and anions not having same number of electrons and protons. But protons value same for parent. Parent means neutral one. And ions. This is about atomic number. Write the running notes, all of you. Next one. Mass number or atomic mass. Mass number or atomic mass. Atomic mass. Atomic mass is denoted by the symbol A. A equals to it is taken as one atom. The total mass of this atom concentrate at one point. That point is called nucleus or center. So best example for this one. Wait. Yeah, is it possible or not? Yes, possible. Why? I kept my finger exactly at the center of the book. Okay, now I will change my finger position of the. I will change my finger position here. No possibility. No possibility. No possibility. No possibility. Why? The reason is the total mass of this book concentrate at a center position. Similarly, the atom's total mass is also concentrate at center position. What is the center of the atom? Nucleus. What type of particles present inside the nucleus? Protons and neutrons. That some value is called atomic mass. Very simple. A equals to number of protons plus number of neutrons. Number of protons plus number of neutrons. It is very simple. Sometimes this one also written in another way, that is in any neutral, only it is applicable for neutral atom. Number of protons equals to number of electrons. So number of electrons plus number of neutrons. Number of neutrons. Right? So this is about atomic mass. Element representation or element symbol. How can you write an element symbol? This is most important. For any element, for example, it is an X is an element. This is then written as in down position Z, atomic number, in upper position A, or X Z A. Best example for this one, carbon. Carbon atomic number is 6 and atomic mass or mass number is 12. Or also write like this, C6. Another example, sodium. Atomic number is 11 and mass number is 23. Or sodium 11, 23. This is our first class. Most important topics we are discussed in this class. Right? What is an atom? What is molecule? What are fundamental particles and what are subatomic particles? Atomic number and mass number. Right? In our next class.